This is the first lecture in the FOA series on premises cabling. In this lecture, we'll look at what is premises cabling. The FOA has published a textbook on premises cabling called the FOA Reference Guide to Premises Cabling. You can get a copy of this book from Amazon or most online or brick and mortar booksellers. We also have an extensive section on premises cabling in the FOA Online Reference Guide, which you can find from a link on the FOA homepage, www.thefoa.org. In the premises cabling section on our website, you'll also find links to Uncle Ted's Guide. Uncle Ted's Guide to VDV Cabling is the place that lots of people get started. It's the beginner's guide. It tells you about the jargon and the basic ideas behind VDV or premises cabling. It's a good place to start, and it's where thousands of people have gotten their start in this technology. So what is premises cabling? Premises cabling is the cabling indoors, inside the premises. It's inside buildings and on campuses. It's the cabling that's used to support voice, data, and video communications, as well as security systems and other types of systems that can operate over low voltage cabling. Premises cabling is generally customer owned, and it involves many different cabling types, but primarily unshielded twisted pair, fiber optics, and coax. Interestingly enough, premises cabling is a standardized cabling system that doesn't have a standardized name. Some people, like the FOA, call it premises cabling because it's the cabling inside a building. The standards generally refer to it as structured cabling. Some people call it VDV for voice, data, and video cabling. Or maybe data cabling, low voltage cabling, limited energy cabling, telecom cabling, teledata cabling, you name it. There's lots of different names, but it's all the same. What we're talking about here is basically a standardized premises cabling architecture developed by vendors, the people who make it, to ensure the interoperability of networks that are designed to run on this type of cabling. It's basically a flexible cabling scheme for fiber optics and copper designed to be installed without regard to its ultimate use, because it can support voice and data and even video for short links. Because it's standardized, it allows easier moves, adds, and changes, and upgrading to different network types. It's not mandatory like the National Electric Code, but it's followed generally for interoperability. The standards for premises cabling were developed from a 1982 AT&T survey of a number of businesses. AT&T was interested in what was going to happen when they went from POTS, plain old telephone service, analog phones, to digital private branch exchanges and digital phones. In their survey, practically all of the stations were less than 300 feet from the wiring closet, and 95% of all desktops were within 50 meters. This thus became the standards that were used for development of structured cabling. Since that AT&T survey, a lot has happened in premises communications. We've had the development of PCs and PC networks, the demise of the mini-computer, the domination of networks by Ethernet, networks over unshielded twisted pair cable, and 10 generations of network copper wiring. We've had the advent of fiber optics, the internet, and the World Wide Web, and how that's affected networks and communications. And we've had wireless phones and networking developed to compete and work with premises cabling. We've also had the development of hybrid fiber coax cable TV networks offering internet access, the development of fiber to the home because fiber became cost effective for connecting the subscriber directly. We've seen structured cabling in homes, voice over IP phone systems, security systems using structured cabling, and the advent of even delivering power for some devices over the structured cabling system, what we call power over Ethernet. One of the driving forces for changes in premises cabling has been the growth of speeds in Ethernet, the protocol used for most networks on premises cabling. In 1982, when AT&T did their survey, Ethernet was barely running at 10 megabits per second over coax cable. Today it runs 100 gigabits per second over fiber optic cable, and that has caused major changes in the premises cabling standards. Phones have changed a lot since 1982 also. In 1982, most phones were still POTS phones, working not much different than when Bell invented them in 1876. Today, most phones use voice over IP, transmitting digitally over Ethernet networks, or of course, they've gone wireless. In the same time frame, we've seen 10 generations of copper cabling required to support the increased speeds of Ethernet networks. Ethernet originally ran on ThickNet, a large coaxial cable, moved to ThinNet, a thin coaxial cable, and then to unshielded twisted pair. And now we've gone through 6 or 7, depending on how you look at it, generations of unshielded twisted pair. Mostly using modular 8-pin connectors, but we've also seen with the very high speeds of the latest systems some proposals for different types of connectors with better high-frequency performance. In the same time frame, we've seen 3 generations of optical fiber, multi-mode fiber, and then into single-mode fiber. We've seen about 100 proposed connectors, but in reality only 4 connectors were used during most of that time frame. This graph shows how UTP, unshielded twisted pair copper, and fiber optics have been developed over the same time period to provide for faster transmission of communication signals. And you can see that generally speaking, fiber has maintained its 100-to-1 bandwidth advantage over copper over the period. But copper remains popular simply because people are familiar with it and always seem to be of the mistaken impression that fiber is hard to install or more expensive, neither of which is currently the case. Here's the ancient history of premises cabling. It's a computer in a computer room with hubs talking to more electronics in a telecom closet and going out to a workstation somewhere on a desktop. Premises cabling today is really quite different. We still have a computer room, but we call it a data center, and we have a telecom closet, but we call it a telecom room. We have backbone cabling, and although it can be either copper or fiber, it in large networks will almost invariably be fiber for its higher bandwidth capacity. Horizontal cabling still exists and is usually copper going to a work area on the desktop, but we also have connections out for wireless access points. And the reason is that most users today have laptops, not desktop computers, and they have other mobile devices like tablets and smartphones that connect on wireless. So we now see that premises cabling, at least in the traditional way, is changing to being a network to support more and more wireless users. The other option today is to go to centralized optical fiber. If we use fiber, not just for the backbone, but the connection to either a desktop or a wireless access point, we need no electronics between the data center or computer room and the end device, be it a wireless access point or a small mini hub for the desktop. We've even seen the development of centralized fiber networks based on fiber to the home technology, which are called passive optical LANs, that offer gigabit and above speeds with ease using pre-terminated, prefabricated systems for installation. We've also seen several different applications for premises cabling, including running video over UTP for closed-circuit television security systems, intrusion alarms, card entry systems, building management systems. Practically anything that runs on copper cabling in a building is now set up to run on standard structured cabling systems. This lecture is a presentation of the FOA. You can go to our website and find hundreds of pages of technical information on premises cabling and fiber optics, all free.